This is Mr. Martin. This is video notes for section 6.2. We're going to be talking about perpendicularity of a line and a plane. So a little bit different than two perpendicular lines. So make sure if you have any questions you ask me. So start out with the definition. If a line is perpendicular to a plane, then it is perpendicular to all lines in the plane passing through the foot of the line. So if you remember, the foot of the line is where the line goes through the plane. So in this case, in our diagram, B is the foot. And we can see if this line that's going through the plane is perpendicular to the plane, it's going to be perpendicular over here, and it's going to be perpendicular over here, and it's going to be perpendicular over here. So any line that would pass through B would be perpendicular to the line passing through the plane. So a couple of notes here. Make sure you can distinguish between the difference between two perpendicular lines and a line perpendicular to a plane. And then a line can intersect a plane and be perpendicular to a line in the plane, but not be perpendicular to the plane. So I'll see if I can draw a picture here for you. So here's our plane. And I'm going to draw a line in the plane. And then I'm going to draw a line that goes through the plane. Here's the foot. So we can see that it's not perpendicular to the plane. Otherwise, I would have drawn it sort of up and down. But if this angle right here is a right angle, it's perpendicular to that line in the plane, but it's not perpendicular to the plane. So again, make sure you ask me some questions in class if you are having trouble with that concept. All right, so next theorem. If a line is perpendicular to two distinct lines in a plane that pass through its foot, then it is perpendicular to the plane. So if we're trying to prove that a line is perpendicular to a plane, all we need to do is prove that it's perpendicular to two different lines in the plane, again, that pass through the foot. So AF is perpendicular to BF, that's one line in the plane, and AF is perpendicular to CF, that's a second line in the plane. So since AF is perpendicular to two lines in the plane that pass through its foot, it would be perpendicular to M. So we would say line AF is perpendicular to M. Okay, so again, this means that to prove a line is perpendicular to a plane, we only need to show that it is perpendicular to two lines in the plane, again, passing through the foot. So let's take a quick look at a quick example here. We're given that segment PF is perpendicular to the plane, so we know that it's going to be perpendicular to all the lines in the plane that pass through its foot, and the foot here is F. And we know that PG is congruent to PH, and we want to prove G is congruent to H. So really, it's very similar to what we've been working on for quite a while now. We're going to prove two triangles congruent, except now the two triangles are not in the same plane, so we're looking at a three-dimensional figure. But all of our other things are going to work the same way. So we've got segment PF is perpendicular to K, and we've got segment PG is congruent to segment PH. And again, if you want to pause the video and work this out on your own, that would be fine. So this is our given information. So since PF is perpendicular to K, I know that PF is perpendicular to GF, and I know that PF is perpendicular to HF. So if a segment is perpendicular to a plane, then it is perpendicular to all lines in the plane passing through the foot. A little lengthy. And then since I've got that these are perpendicular, I'm just going to put some numbers in here to make it easier to name those angles. I know that angle 1 and angle 2 are going to be right angles. Angle 1 and angle 2 are right angles if segments are perpendicular, then they form right angles. So I'm going to have the right angles congruent next. And then I'm going to have PF as a reflexive side, so we'll be able to prove those triangles by hypotenuse lag. So I've got angle 1 congruent to angle 2. All right angles are congruent. And I've got that PF is congruent to PF by the reflexive property. And then I can say that PFG is congruent to PFH. Triangle PFG is congruent to triangle PFH, again by hypotenuse lag, and my steps were 2, 5, and 6. And now that I have the triangles congruent, angle G is going to be congruent to angle H by CPCTC. So if you pause the video and your solution's a little bit different, make sure you ask me to see if it's okay or find out what you did wrong. And as always, if you did have questions, make sure you write them down in the margins and ask me the next time you see me in class. See you next time.